Hey, what's going on? It's Jason again. Just showing you one of my most recent projects that I made for Halloween. Now that I had a bit of a time before Halloween actually started, I had was able to make some nice decorations, which involved some making some tombstones out of rigid foam, you know, decorating them like that. But I really wanted to go a little bit further and make something maybe a little more active in my display. So I made a coffin that has a fog machine in it and would open up automatically. So we'll start talking about that. So my main intentions were to have a coffin that would respond to some input like trick-or-treaters walking down the driveway, and then it would open up and spray the fog, and they would see that as they're walking towards the door. This Halloween was very rainy, so I never fully got the project going. The only thing I didn't have was that trigger sensor, so this just meant that the coffin would go through its opening and closing and fogging cycle basically repeatedly. As soon as the door closed, the fog would spray and go through that cycle. So it wasn't a big deal. The only thing about that was that the fog machine was running for 2 hours, or the coffin was running for 2 hours, and it overheated, so then it stopped working. But next year, if I still have it and I use a sensor trigger, you know, like a proximity or solid motion detector, then it'll be able to run less frequently and maybe not overheat. So I'll give you an overview of how this thing works. So this is the main drive motor that I used. It's the incline motor for a treadmill that I found on the side of the road. It has, it's an AC motor, and I believe there is some sort of sensing potentiometer harness attached to it, but I didn't figure out how to use that one. So what I did was I just hooked the power basically up to the my control system, and depending on which way which wire was energized would determine the motor went up or down. I did have some nice linkage here, with basically having this extra little link in here allowed for discrepancies on that angle. Yeah. Now, because this is a worm gear, it has a lot of torque, so I wasn't worried about being able to lift this door. So once I figured that out, then I needed to be able to determine how to stop it. And without the potentiometer circuit, I would need some sort of maybe ultrasonic sensor. So that's what this is right here. My first rendition had it on the door over here, but due to the angle of the door, it wasn't getting an even measurement, a distance measurement, so sometimes it wouldn't function. So I went with this here, which just uses this slight surface here that's attached to the arm to determine how high it goes. Here is the Arduino circuit that I used. So I have an Arduino Mega and a 4-channel relay, which is what I used for the motor control, up or down basically. So I had the power going in one way on one relay and the power going in another way on the other relay. Here's the fog machine, which is just a 400-watt fog machine. But this one, it comes with a controller that basically would show you when the fog machine is heated. There's a light underneath this, and then an activation switch. But my intentions weren't to sit outside and watch the coffin and energize it when people walk by. So I had to determine a way to sense that the fog machine was ready. Since it uses 115 AC power, I wasn't really able to connect that to the Arduino directly to sense that voltage. So what I did was I used a photo transistor here that is connected to an analog input of the Arduino. And when the light energizes, it allows a little bit of current to pass through the photo transistor, which then the analog input would sense that change and then know that the fog machine is warm. the energizing switch was just connected to one of the 4 relays. I think it was this one right here. And then that would energize, which would then be similar to pushing the control circuit and energize the fog machine. The final thing that I thought about is like, what if I needed to maybe do some maintenance on it, and by maintenance, I mean, if I need to say stuff it inside, put something inside, or I wanted to store it and have the door closed. And I didn't really want to disconnect this lever every time that I did that. So how I did that was I put in this switch here that in the center would be in the run mode, and then one way would cause the door to go to the top, and then the other way would close the door all the way. And this reset button here would reset the Arduino, which then the first thing in the code that it does is meant to read the state of the switch and then do it otherwise. So currently it's in this position, or this position right here to one side, which leaves the door open. If we put it to the other side completely and double click that, then the door will cycle through its closing sequence. I did it like this, so then in this kind of intermittent closing sequence, which is the same for the opening method. So then for some reason, if the door was halfway, I stopped it halfway, there would be a way to get it to return to its basically initial state. So now it's in the store mode, so basically I could just unplug it from the power bar there. Instead, so we'll gotta get it running. So we'll put it in the middle, click the reset button, and we should just wait for that fog machine to start. And the fog machine is firing. You can see it spraying out there. In the code, I have that relay trigger for 10 seconds, which may be too much. Right after the fog sprays, the door will open and the fog will come rolling out. Which in the garage here, it's not very effective on trying to see the process. So the door stays open for 4 seconds, and basically then the door closed and it cycles. As you can see, it doesn't close in that kind of intermittent fashion. I timed how long it took to open or close, and basically from its open or close point, 20 seconds of closing time was enough to get it where I needed it. And plus that linkage that I included underneath the door here allowed for any discrepancy in the time. So we're fogging again, so I'm going to stop that. So if I just trip into that, into open, put it in open mode, it'll cycle through the just going to run the fan a little bit to help get this fog out. Yeah, it's pretty foggy. Come on. So I'm inside now, and I'll show you the code that I used to make my Coffin do what I want it to do. So I'm using the Arduino Ide program that you can get from arduino.cc, and it took a little bit of time to develop this program. I figured that the best way to do it would be a whole bunch of smaller functions, so then I can use them when I need. So the main, the initial part here is me setting up the pins. For more information on actually learning how to use Arduino, you should probably go to the Arduino website. So I have a lot of pins there. The first 2 pins are for the ultrasonic sensor. The second 2 are the pin that runs the relay to open or close the Coffin. Fog heater pin is the phototransistor that senses the light on, which is the heater go basically for the fog. The fog go pin is the pin that triggers the relay to run the fog machine. Maintenance pin and store pin are the pins on the switch that I have there. That'll open or close the door essentially. And then I set the open limit and close limit, which is just a measurement of the ultrasonic device. Then I have some variables there to store the value of the switch, so then it maintains that state. We have 6 in and outs for this, as you can see there. So the main loop is actually fairly small. I have initialize function and a switch check, so I'll run through the functions themselves, and then we'll understand why I have the loop as small as it is. So the main thing here is switch check. So that's the switch that I was talking about in the garage there, that will determine if the coffin door opens or closes, or if it goes into the run state. And basically, so I have it read the switch as there's 5 volts set to it. So depending on which way it is set will determine which one of these is active, which then we check here. If maintenance switch is high, then open the coffin. If it's in the opposite direction, high, then close it, or else run. So run would be basically what I wanted to do when I want to leave it. So so we check the switch again to make sure that it stays low, and we're going to close the coffin to make sure it's closed. We're going to do a heater check. So that's just basically just going to see if the fog machine is ready to go. This commented out section right here is trigger sensor. So this is where I was going to have some sort of sensor to sense the trick-or-treaters walking by, or a motion detector or something like that. So in there, I was just going to check to see if that happened. Then fog go is the triggering the relay to actually make the fog machine spray. Then we have an open coffin. Initialize. So initialize is basically just a way of resetting the relays as the relays open with a low signal to it. So often they already have a high, and the switches will be engaged when you don't want them to. And then the door stays open for 4 seconds, 4,000 milliseconds, and then we close the coffin. For the heater check, we're basically checking the analog pin. So while the analog read fog heater pin is less than 5, so that means when the phototransistor is not conducting at all, the voltage on this pin would be 0 more likely. And so once we get to the heater check, we stay inside that loop until the fog machine has heated up, and then we'll wait 2 seconds after that, which then leads to the fog go. Again, it's going to do a heater check just in case, because Halloween is cold, so the fog machine may actually go not ready. So we do another heater check, and then we will make the fog machine go high for a short period of time, which is down here. Digital write fog go pin low, which then triggers the fog machine. So initialize, I just basically make all my relays high, which is closed, so there's no power flowing through the relays, and that's just so then we don't have something triggering when we don't want to. Now I have 2 different open functions and close functions. So we have open coffin full, close coffin full, open coffin safe, and close coffin safe. So as I mentioned in the garage, the closed coffin safe and open coffin safe are basically step style kind of closing. So it closes it for 2 seconds and then checks again the ultrasonic sensor to see how far the door is from being in the closed state. And then I have open coffin full, which shows the 18 seconds that it takes for the door to open properly. And this would be the ultrasonic sensor code that comes with the Arduino. You can just look that stuff up. So again, back up to the main loop. So the main thing we have here is to initialize. So that again will make sure the relays are not closed right now. And then we do a switch check. So within the switch check, we'll do the check to see what way the switch is, or if it's in run, which then it'll hop to run. and that's basically it. It's actually not very complicated. There seems to be a lot of wires in the box, but it's fairly... There are a lot of wires inside there connected to the Arduino, but if you just take your time and connect each sensor very slowly, then and create different ways with the Arduino code to check each sensor, so then you can verify that once you connected it, it does function as it should. And I definitely did a lot of testing with a little breadboard and using switches or just connecting things to 5 volts to determine if the code is going to respond correctly, but it has. So I'm pretty happy the way it worked out. So here, I'll show you how it went that night.
Jason's Halloween project.
Anyway, thanks for watching again. I'm a little slower on the videos these days. It's now becoming a little bit colder, so there's less boat videos and maintenance and stuff, but I know in the spring that we'll probably get to that. One thing that I didn't show was that I wrapped the boat and it's all put away for the winter, so hopefully the wind doesn't blow that off. Yeah. Anyway, talk to you later.